Okay, we're going to be reviewing Chapter 7 for your test. So the first thing you covered in Chapter 7 was the different quadrants. And you need to make sure you know what the quadrants are. So usually they write them with Roman numerals. It goes counterclockwise, first, second, third, and fourth. Remember your y-axis, your x-axis, and your origin. The points in this section, so if I go over 3 up 4, they're both positive on this one. If I'm going to end up in the second quadrant, my x value is negative, my y value is positive. Same here with the third quadrant. Both my x and my y are negative, and over here in the fourth, you get a positive x but a negative y. All right, so now let's just graph just a couple points. First, 5, negative 3. So the first number is your x. It's the which way you go on the x-axis. So it's a positive 5. I go in the positive direction. And negative 3. And we mark that with the point right there. Negative 2, so it tells me I'm going to go negative, and then positive 4. Negative 2, positive 4. Now let's determine if this point is actually a solution for this equation. All you have to do is take the equation, y equals 2x plus 5, and in place of the x, you're going to plug the 1, and the y, you're going to plug the 7. So y is 7, x is 1, y equals 2 times 1 is 2, plus 5, and 7 equals 7. Since I got a correct answer, 7 equals 7, then I know this is a solution for this equation. So now let's try another one. Let's go ahead and rewrite the equation. 2y plus 4x equals 8, and our point is 0, negative 4. So for the x it's 0, negative 4 is our y, so 2 times negative 4 plus 4 times 0, I get negative 8 plus 0, and I get negative 8 does not equal 8. So it does not work for that solution. Now you guys were asked then to find 3 solutions for another equation and then graph it. Now when we do that, you use a t-chart. You can pick anything you want. You could pick what the x's were going to be, what the y's were going to be, but whatever you pick, you put into the equation and find the other half. So for example, I like to use 0, 1, and 2. So first we take our equation, y equals 3x plus 2. We plug in x is 0. So 3 times 0 plus 2. And what I get is 0 plus 2, so y is 2. Try it again. Let me see how much room I have. Okay. Y equals 3 times 1 plus 2. Y equals 3 plus 2, which equals 5. And then my last one, I'm going to slip up here to do. Y equals 3 times 2 plus 2. So y equals 6 plus 2. So y is 8. Now I'm going to graph it. And all I'm going to do is draw a graph. I'm going to do 0, 2 puts me here, 1, 5. And then the last one's kind of off my chart here, but we'll make it work, is 2, 8. And then you need to use a ruler. And we graphed it. Okay, so finding solutions and graphing. All right, so we're talking about a linear equation. A linear equation is an equation of a line. So for example, y equals 3x plus 2. If I were to graph it, it would create a line. So let's go ahead and graph this one. So the first thing I'm going to do is I'm going to draw my graph. And if you're not really good at being straight, this might require a ruler as well. There's a couple of ways to graph this equation. What we're going to do this time is a t-chart, and a little bit later in this one we're going to practice using the y-intercept and the slope to graph. So again, I'm going to make my t-chart. Pick your numbers. I again like 0, 1, and 2. There are going to be times where that's not the best choice to make, but right now it's okay. So let's see what happens when x is 0. So I'm just going to plug it in. 0 plus 2y equals 8. I get 2y equals 8. Opposite operations to get the y by itself. It's multiplication, divide by 2, y equals 4. So I'm looking at 0, 4, my first number. So now I'm going to see what happens when x is 1. So I'm going to plug it in here. 1 plus 2y equals 8. I'm going to move that y over. Remember that you have your mirror still. 1 minus 1 does give me 0, and I'm left with 2y equals 8 minus 1, which is 7. Opposite operations, it's 2 times y, so divide by your 2. Y equals 7 over 2. You're going to get answers that are fractional. It's not that big a deal. What I do is I say, okay, this is my answer, but so I can graph it, I'm going to write it as a mixed number. 2 goes into 7 3 times with 1 left over. Okay, so I'm looking at 3.5. So I go over 1 and up 3.5. Puts me right about there. I'm not perfect, but it's close enough. One more number, we're going to do x is 2. Subtract that 2, and I forgot my mirror, from both sides. This does give me a 0. 2y equals 6. Again, opposite operations. 2 times y, I'm going to divide. Y equals 3. So over 2, up 3. And now I'm going to use my ruler to make my line. When you go to draw the final line, I really expect to see that ruler coming out. All right, so graph using intercepts. So you can use the x and the y intercept to graph, and again, you're going to look back in your notes if you don't remember this, and you'll see it. And that's just that the x-intercept is where it crosses the x line, y is where it crosses the y, and we'll look at how we do that. So let's look at this equation. We have 4x minus 3y equals 12. And let me put in a disclaimer. I do not care how you graph. If it asks you to graph something, then use the one you're most comfortable with. If you like the t-chart, always use a t-chart. If you like using slope and y-intercept, use slope and y-intercept. If you like using the intercepts, use the intercepts. I'm going to show you all three. You make your choice. So we're going to look at what happens when x is 0 and when y is 0. Those are your intercepts. So x is 0. I'm going to come up here in the equation where the x is and plug in 0. 4 times 0 is 0, so I get minus 3y. Again, solving an equation, multiplication, I divide, y equals negative 4. So now, what happens if x is, or y is 0? So we go, okay, 4x minus 3 times 0. 3, 0 is 0, so I get 4x equals 12. Divide by 4. By the way, x equals 3. So now when I go to graph this, (0, negative 4) is the y-intercept. So when it gives you a number other than 0, see how it's the y that's not 0? The 0's into the x, that's your intercept. So if I'm saying, okay, what's the x-intercept? Oh, that's the one that has the 3 for the x, because it's going to cross the x right here. And then, now the one thing you can do, and I suggest strongly, is when you're graphing with y-intercepts, you want to think about maybe plugging in one more number and checking it. So in this case, maybe I want to see what happens when x is 1, or maybe when x is 2, and see if it falls on here, that when I come to 2, I'm looking like, yeah, I'm right about there when I do it with 2, just so you can double check yourself. Okay, looking at horizontal and vertical lines, if we're going to graph them, okay, this is a horizontal line. It's when y equals something, and the vertical line is when x equals something. If you forget that when you start graphing it, you'll see it. So what it says is it says y equals 2. So no matter what in the world happens, y equals 2. So if I had 10 that I had to plot, all 10 would have y equals 2. So all we know is y equals 2. That means every x works. So I can just go, okay, then what happens if these are the x? Great. Y equals 2. That's all I'm worried about. Y equals 2. So 0, 2, 1, 2, 2, 2. And you can see that if you forget that the y is the horizontal line, just plug it into a t-chart, take a few seconds, and go, oh, that's right. Now, again, here it tells me the x is always negative 3. Doesn't say anything about the y, then it doesn't care about the y. So 0, 1, and 2. So negative 3, 0. Negative 3, 1, negative 3, 2. And again, like I said, when you forget which one's the vertical, which one's the horizontal, just graph it real quick. And then you go, oh, that's right, horizontals are horizon, vertical line, up and down. All right, so now let's talk about slope. With slope, we're talking about the rise over the run. So if I'm looking at the slope of this line, it's how far I go up and how far I go over. So in the case of this line, it's 1, 2, 3, 4. I go up 4, and I go back 1, 2, 3, 4, 5. When I do my slope, I always go up, and I make the decision if it's negative or positive by the way that I go left or right. So in the case of this, if I'm going this direction, I'm going down into the negatives. So that helps me remember, oh, that's right, if I'm going to go this direction, it must be negative. If I go this way, I know it's going to be positive. It goes towards the positives. So now, if I'm given 2 points, I can find the slope in this possibility. y2 minus y1, x2 minus x1. So let's try some problems to see how that works. So graph and find the slope. All right, so first it says graph and find the slope. So 0, 9. Ooh, way up there. 4, 7. All right. So now I'm going to graph it. That means I'm going to connect the 2 dots. All right, my slope, I'm going to go up 1, 2, it's right here. I'm going up 2, but I'm going backwards 4. So rise over run, which I can rewrite because I can divide both the top and the bottom by 2, 1 over negative 2. That would be my slope.